The foundation. What is an inventory system? An inventory system is a crucial tool for businesses. It meticulously tracks the goods a company holds. The system records the quantity of each item. It also notes their specific locations if applicable. This information is fundamental to operations. Without it, a business operates blindly. Knowing what you have is the first step. Knowing how much is equally important for success. This allows for informed decision-making daily. It forms the backbone of commerce. The relevance of a robust inventory system is paramount. This is especially true in today's digital marketplace. Online businesses or e-commerce platforms depend heavily on it. Customers expect accurate stock information instantly. If the website says an item is available, it must be. Incorrect data leads to disappointment. This can damage a brand's reputation significantly. Happy customers are repeat customers. Accurate inventory ensures a smooth purchasing journey for everyone. The rush hour challenges of high-volume inventory. Online businesses face many inventory system challenges. The primary challenge is concurrency. Many users access the system at the same time. They might try to buy the same limited item. This creates a high-stakes environment for data integrity. The system must process numerous reads and writes correctly. Reads are when users check stock levels. Writes occur when a purchase deducts stock. Ensuring these operations are consistent is difficult. This complexity grows with more users. Race conditions are a common problem in these systems. Let us consider an example scenario. Imagine one last popular concert ticket is available. Two users, Alice and Bob, see it online. Both Alice and Bob click buy at nearly the same moment. The system first reads the stock one ticket. Alice's request proceeds to deduct one. Bob's request almost simultaneously also reads one. If not handled carefully, both might buy the ticket. The system might then record negative stock. One customer will be very unhappy. A basic database schema for inventory is quite simple. We need a table, perhaps named. This table would have a few key columns. One column is this uniquely identifies each item, like a specific shoe model. Another vital column is this stores the current stock level for that product. We might also include this records when the stock level was last changed. This simple structure is the core. Without proper technical solutions, problems will arise. Overselling, as seen with Alice and Bob, is frequent. This leads to cancelled orders and customer frustration. Data can become inconsistent. The database might show a different stock level than reality. This makes planning and restocking very hard. System performance can also degrade significantly. Users experience slow loading times or errors. Ultimately, the business suffers financial and reputational losses. These issues must be proactively addressed. Building defenses, ensuring accuracy with locking and isolation. To prevent issues like race conditions, systems use locking. Locking is a mechanism to control access to data. When one process needs to update inventory, it requests a lock. While it holds the lock, other processes must wait. This ensures only one user modifies a specific item's stock at a time. It's like a single-person entry rule for a sensitive area. This prevents conflicting updates. The goal is to serialize changes to shared data. This maintains consistency. Pessimistic locking is one common approach. It assumes conflicts are likely to happen, so it locks the data record performing an operation. When a user tries to buy an item, the system first locks that item's inventory record. For example, this clause tells the database to lock the row. Only after the lock is secure does the system check quantity and update it. If the lock cannot be obtained, the process waits. Transaction isolation levels are also critically important. A transaction is a sequence of database operations. These operations are treated as a single unit. Isolation determines how transactions are protected from each other. A high isolation level is very safe. It makes concurrent transactions behave as if they ran one after another. This prevents many subtle bugs. Simpler levels offer less protection. Choosing the right level is a trade-off. Higher isolation can reduce concurrency. Pessimistic locking works alongside appropriate transaction isolation. When a transaction begins to update inventory, it acquires a lock. The isolation level ensures that this transaction's changes are not visible to others until committed. It also ensures the transaction sees a consistent state. For example, with or the quantity read will not change unexpectedly during the transaction. This combination provides strong guarantees. It ensures that each purchase accurately reflects and updates the true stock level. This accuracy is fundamental for trust. Speed and reliability. Caching reads and final thoughts. Inventory systems often handle many more read requests than write requests. Think about an e-commerce site. Hundreds of users might browse product pages for every one user who makes a purchase. Each page view might trigger a check for item availability. Constantly querying the main database for every view can be very demanding. This can slow down the database server significantly. It can also increase operational costs. We need a way to serve these reads faster. Caching is an excellent solution for high read volumes. A cache is a temporary, fast storage layer. It sits between the application and the main database. Frequently accessed inventory counts can be stored in this cache. For example, Redis or Memcached are popular caching systems. When a user views a product, the system first checks the cache. If the stock count is there, it is returned immediately. This is much faster than querying the database. This reduces load on the primary database. Effective cache invalidation is crucial for accuracy. If stock levels change, the cache must be updated. Otherwise, users will see stale, incorrect information. When an item is purchased, the database stock is reduced. Immediately after, the cache entry for that item must be cleared or updated. This is right through or right around caching. Another strategy is time to live, TTL. Cache entries expire after a short period, forcing a fresh read from the database. The chosen strategy depends on tolerance for slight staleness. In conclusion, mastering high TPS inventory design is achievable. It requires careful implementation of technical solutions. Pessimistic locking and strong transaction isolation levels protect data integrity during writes. This prevents overselling and maintains accurate stock counts. Caching strategies effectively handle high read volumes. This ensures the system remains responsive and fast for users browsing products. Together, these techniques create a robust and reliable inventory system. Such a system can support 10,000 requests per second. It improves user experience and builds trust.